we had A minus B, and we said that was what? 1, 3, 5, and 7. A minus B was 1, 3, 5, and 7. Any questions on that? 1, 3, 5, and 7. Okay? A prime. 0, 8, 10, 11, and 12. That's what you should have. Any questions there? Alright. C. First of all, you had to find what was in parentheses. You had to find A intersect B, right? What's A intersect B? 2, 4 what? 2, 4, 6. But then it was a little prime mark on the outside, right? So that means what's not in that set. And that in that set was 2, 4, 6. So what was not in 2, 4, 6?
0.
What was not? We're talking about C. Doing A intersect B, which is 2, 4, what? 6, right? So we want what's not in that set. What's not in that set? 0, 1, 3, 5, 7, and 8. Now 8, and what else? 10, 11, and 12. Good. 10, 11, and 12. Any questions there? Now, at that point, it says intersecting C. So intersecting C, C was what? 0, 1, 2, 3. So now we got 0, 1, 3, 5, 7, 8, 10, 11, and 12 intersecting 0, 1, 2, 3. So what do they have in common? 0, 1, 3, right? Any questions? Going once? Okay. Here we got A intersect B intersect C. Well, remember we got to use order operations, but you still do it from left to right. So you're going to do A intersect B first, which is what? 2, 4, 6. We already had that from the previous one. But then 2, 4, 6 intersecting C, which is 0, 1, 2, 3. So therefore, what intersects there? Just 2. Anybody lost? Good. All right. Moving on. E. Left to right. A union B. A union B will be who? 1, 2, 3, 4, 5, 6, 7, and what? 8. Okay, that's A union B, because everything in A, everything in B, and what they have in common. Just don't repeat any items. Now you want to union what's not in C. What's not in C is 4, 5, 6, 7, 8, 10, 11, and 12, right? So then at that point, you got to union both of those sets. So your answer, final answer should be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, and 12. But you don't keep it over there on the board, please. A intersect B, union C prime. A intersect B, which is this piece right here, we said was 1, 2, 3, 4, 5, 6, 7, and 8. Is that correct? A union B. Is that correct? Mm-hmm. Everything in A and B. What I have in A is 1, 2, 3, 4, 5, 6, and 7. So we got 1, 2, 3. I got 4, 5, 6, and what? 7 intersecting union B, which means everything in B2. We got 2. We already got 2 listed. We have 4 already listed. We got 6 already listed. All we needed to add was 8, right? Hello?
Yes.
And at that point, now we're going to go to union, not C. What's the not in C? Well, C we got 0, 1, 2, 3. So it'll be everything else. So we don't have 0. We don't need 1, 2, and 3. So at that point, we're going to have what?
4,
5,
6,
7, 8, 10, 11, and what?
12.
12. Well, what does union mean? Come on, what does union mean?
Combine.
Everything in this one and everything in what?
Next one.
Do you have to repeat anything?
No.
No. Okay? You don't have to repeat anything. So if you're not going to repeat anything, let's go. We got 1, 2, 3. We also got 4. 4 is over there. We have 5, 6, 7, and 8. We already got 5, 6, 7, and 8 from there. And then we got to have what?
10, 11, 12.
That's it. And that's how you do. Any questions? All right. F. We got to do each parentheses So we're going to do A union D. What's A union D?
1, 2, 3, 4, 5, 6, 7, 10, 11, 12.
Okay. You want to write that on the board too?
Yes.
Everybody have this one?
Yes.
We good? Alright, so A union D, and then it says intersection C prime union B. So A union D. A union D means everything in A and D. So that's going to give me everything in U and A and D. So that's 1, 2, 3, 4, 5, 6, 7, 10, 11, and what?
12.
12. Everything in A and D as well. Okay? Now we want to intersect. Now we're going to do this piece right here. Well, we want what's not in C. What's not in C? I'm going to do this to the side. We already say didn't we say what was not in C already? Which was what? 4,
4, 5, 6, 7,
8, 10, 11, and what?
12.
12. But then we wanted the union with who?
B.
B. And what was B? 2, 4, 6, and who?
8.
8. So then if there's going to be a union, it's this and this together, right? So at that point, we're going to have 2, 4, 5, 6, 7, 8, 10, and who?
11 and 12.
11 and 12. That's what we're going to have. Any questions on that? Yeah.
You got the
Oh, it's the tilde mark on the outside?
Yes.
All right, sorry. Thank you. I didn't see that. All right. Roll on top of it. All right, so what's not in there? So this is not what we're looking for right here. We got to, let's do this. I'll put a prime here. So then what we're going to have is 1, 2, 3, 4, 5, 6, 7, 10, 11, and 12. All right, intersecting. What's not in this set? Okay? What's not in that set? We got who?
0, 1,
1,
3,
3, 5 is in there, and 8 is in there. 4 is in there as well.
that's it.
Okay, so it's just 0, 1, and who?
3.
3. Okay. Then at that point, now we're looking for what intersect between those two, right? That's what this means, intersecting. And what intersect?
1 and 3.
1 and 3. Any other questions? Yes.
I'm getting confused between the union and intersect. Like, I get the union.
Hold it. What does intersecting mean?
Yeah, that's where I'm having this.
I'm going to ask you, what does intersecting mean?
Does it mean everything except?
Mm-mm.
Okay, so I don't know. I know
Separate out.
union means, like, in simpler terms, bring together.
Okay, let me ask you this. What the word intersect mean?
Like cross.
Cross, which means they're having what?
Being
Common. Right. Common. And that's the thing, yeah, think about that, because when we talk about words, it is actually the same thing. Just make sure you know that the words relate. So intersect, that means where they cross, that means what they have in common. So that's what you're looking for, elements that they have in common, the same element. And what's the symbol look like? The N, right. That's the N. That's what they have in common. And then union is the what? The U. What does union mean?
Everything.
Everything. And both of the what? Both of the
sets.
sets. And what they have what? In common. Okay? And they will have some overlapping at times. Okay? Any questions? Good. All right, let's look at the other page. Now what we're going to do is actually draw out the pictures for each one of the diagrams based on what you have. Okay, so based on what you have. Let's look at 5. So now we can see it from just looking at the set by itself and look at it. We can also look at it from a diagram. So here we have A and B. They want us to do A union B. What does A union B mean?
All of it.
Everything in what? Is everything around here as well?
No, it's just A and B shaded
What's
in.
that? A and what?
What's in B?
B and what's what?
Common.
What they have in common. Is everything in A everything in B. And you will see that A and B actually overlap as well. So that would be our A union B. Okay, question? Move to the next one. So here we have A here and B there. So they're asking me for A intersect B.
Only shade in the middle part.
Only shade in the middle part because it's intersecting what they have in common. That's theta. Only what they have in common. Okay? Now, let me ask you this. Talk about it. Let's see if you get it. This is A. I want A prime. I want A prime.
Okay.
Everything on the what?
Okay.
Everything on the outside. Because this is set A. So it's everything else. Are you following? A prime means everything that's not in A. Okay? Everything that's not in A. And I don't care if I do this. I have A and I have B. And I said I want A prime. Then what is A prime?
Still everything not in A.
Everything that's not in A, and what else?
The B part that's not overlapping.
Right, and B only. It doesn't overlap with A. Okay? So depending on how that picture looks, then you know what you're going to shade. Now let's think about A minus B then. They ask for A minus B.
This is the A part, not the
A only. That's basically what this is called. This right here is A only. This right here is B only. Are you following me?
Yes.
That's the way you look at it. So A only is your A minus B. Here, A minus B. So I gave you A prime then, didn't I?
Mhm.
Okay, so we're on the second row, first column. Okay, that was already given. That's there on the bottom. Now, what is B prime going to look like? You do.
It's
Shade in A and then everything around it.
right.
Shade in A what?
Only.
Only. Shade in A only and everything on the what?
Outside.
Everything on the outside. All right, we're on the second row, last column. B minus A. B only, right? You shade in B only. Anybody need to see those? Good. B only. Good. Now, since you got the idea, I want you to talk to your neighbor, and I want you to do the next two rows. There you go. You have about, I'll give you about 3 minutes to discuss that with your neighbor. So that would be this right there.
What does prime mean again?
Everything except
So for this one, it will be shading everything that's on the outside, right? Okay, cool.
Did you see that? Here it is. This right here is just this piece right here. But they want to take A, and what we're going to subtract out? This piece right here, right? So here's A right here. So if you subtract this out, what are you left with?
That part.
Just A. So this is what you should look like. Any questions?
Nope.
Okay, good. Here we got A union B. Hello? A union B, right? A union B means this, this, and what?
That.
And that. However, it has a prime on the outside. So we want to negate this, right? So that means we're not talking about this, this, and that. We want what?
All the outside.
On the outside. Don't worry about this, this, or that. Because we're negating it. Now, what we know. A prime, and that's just looking at this, we know that A prime is what? If I do A prime, this is A, and that's B. So at that point, if I want A prime, is everything that's right here, and this as well, right?
Right.
Now, if I want B prime, draw another picture. Here's A, here's B. So B prime is this, and everything where? Around that, right? But they're asking me to do what? What overlaps, right? This was, yeah, let me show you this way. I'm going to try to do a different scenario. So we have that, if I go here, here, and here, and we go this, 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 and that, that's my A prime. Got it? We're doing it that way. Now, what I'm going to do is, I guess, do like this. Going like this, that'll be my B prime. So like this. Everybody got it? Now, what am I asking for? What over what? That's what I'm asking. What overlaps? So what overlaps is just the what? Just the outside part. So it's going to be this right here. Just the outside part. Do you see that? This might look for you here. Because you're looking at what only overlaps. And what only overlaps is just the outside part. I know it would be better if I had some colored chalk or something. Alright? We're good? Alright, we here. Here it says A intersect B, which is this piece right here, right? But then we're going to what? Negate that, right? Because we're going to have this. So if we're going to negate that, we want what's not in A intersect B. So what's not in that is this, this, and what? The outside. So we're actually talking about this, this, and the outside piece. The only thing that we're not shading is the what? The middle.
So you don't distribute primes when you're dealing with
No, that's a good question. You cannot distribute Somebody picked up on that. They want to know if you can, y'all remember distributor property, right? They want to know if you can actually distribute this prime here, and that's a no-no. No, 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 no. Now we'll talk about that, okay, in a minute. Talking about demortgage law. That is a good pickup. Cannot distribute that prime. That's not the same thing. Okay? That is not the same thing. Okay? And the reason why, and you see it, and you're seeing it from the picture that we have here. The picture we have here and to there, and you see that they're actually going to be totally different. You see that? And when he was saying distributing the prime, and we already know that the picture here should look like this. So that means no, you cannot distribute the prime. Okay, they're not the same thing. This is not going to be the same thing. Let's go here. A prime is what? This and that, right?
Yes.
B prime is what?
A
This
and
and what?
outside.
And that. It says union. What union means? Everything that we have in what?
Common.
Not everything we have in common, which we don't have anything in common, but actually we do. We got the outside in common. We do have that. So everything here, everything we have in common, and A only and what?
B on.
B only. We're just not going to have that piece there. Any questions? Let's go here. A union B. A union B is this, and that, right? But then we're going to minus out who? A. So we're going to minus out A. We're only talking about who? Middle of B. We're minusing out A, though. So we're going to take A out. So it's just only B. Just only B. Any questions there? Did it make sense? Yes, no, thumbs up, thumbs down. All right?
Yes.
We're going to lose this one. I have how many sets now? 3. I have 3 sets. I have A, B, and C. One thing you're going to see here, next we're going to start getting into Venn diagrams using application problems to use Venn diagrams to solve application problems. And what you're going to have is more than one set. You can have 2 sets, so you can have 3, you can have 4, and so on. And what you see is that they can have all 3 in common. Then what they can have is 2 in common at a time. Like A and B can have this in common only. Here is B and C only that have something in common. And here's A and C only that have something in common. Then you can see it individually where it has only A, only B, and only what? C. You see that? Now let's talk about it. We see this, which was A prime. And that means when we talk about this, when A prime intersect B prime, when we did that, we was talking about just on the outside of who? A and B, right? Just on the outside of A and B. Here, even here, and there. That's this piece right there. Everybody agree with me? And the reason why I did inside of C only because of the fact that that was outside of where?
A and B.
A and B. Okay? Now we want that what intersect who?
C.
C. So I'm going to draw a new picture so you can see what the final answer is. So we have, and I'm doing Mickey Mouse eyes. Mickey Mouse. Does that look like a Mickey Mouse?
No.
It do. Got the 2 ears on top with the hair in front. There it is, right there with 2 ears. Alright, so here's A, here's B, and here's what?
C.
C. Okay? Remember that we were talking about what overlap. So we're talking about intersecting C. Here is C, so that means that my answer is just this piece right here, isn't it? Because if I'm talking about just intersecting C, here is that C right here. Well, if I'm going to intersect C, we're talking about it here. So that's why we actually talk about justifying the answer there. Y'all looking puzzled. Are we good? Are we on the same highway? Everybody going north? Anybody going a different route? Northeast.
I just want to keep going forward.
We're trying to keep doing puzzles. All right. Now, I do want to share with you this. And then we were talking about De Morgan's law. And this is for any set, A and B. A intersect B, and what the complement of that, okay, is equal to Now, what that is equal to, when I do A intercept B, what the complement of A intercept B, it is actually equal to this. It is A, this. But if I'm going to do that and talk about distributing that, if that's what you want to use, you got to do union. You can't do A intercept B if you're going to do that. It's union. So if I'm going to negate this, and if you want to, y'all call it distributing that, then what you got to do is change this to the what? To the other thing. So therefore, what do you think I'm going to do if I do this? A union B. I want the complement of that. What do you think the answer is?
A intercept B.
It'll be
A prime intercept B prime.
Intercept B prime. That's what that is. Okay, that would be the same thing for that. Okay. Are there any questions on that? All right. We're going to start Venn diagram. We're going to start Venn diagram. Now, what's your Venn diagram? So now we're going to use our diagram to actually answer questions that we have. Let's dump that and I'll leave.
Thank you.
You didn't get one? Pass that one over. That way. All right, these two people, right? All right, so I'm going to start getting into Venn diagram. Read your initial problem to yourself. All right, here it says a survey was taken of 150 college freshmen. 40 of them were majoring in mathematics, 30 of them were majoring in English, and 20 were majoring in science. 7 had a double major of mathematics and English, and none had a double or triple major with science. How many students had majors other than mathematics, English, or science? How many students had majors other than mathematics, English, or science? All right. So they surveyed how many people?
150.
150 college freshmen. Freshmen, we're not concerned about that, okay? And it tells me that 40 of them were majoring in mathematics, 30 were were majoring in English, and 20 were majoring in science, and 7 had a double major of mathematics and English, and none had a triple, major with science. So therefore, I see how many different sets? It's 3. What are your sets?
Math, English, and science.
So my sets are math, English, and science, right?
Mm-hmm.
Alright? So I have 3 sets. So I do this. Do I have to make it about ears and a head? Not really. Alright, so now I'm going to name this to be my math. It's the going to be my English, and it's going to be my science. Where would I start if I want to put this in a Venn diagram? I understand the question asking me, how many students had majors other than mathematics, English, or science? Okay.
Well, you need another set, don't you?
I need a what?
Never mind.
How many sets we got? What do we got? Math, English, and what?
Science.
Okay. Math, English, or science.
And the box would be other, right?
Well, it's a Venn diagram. That means that these are students that do not take who?
Math, English, and
or-
science.
Exactly. Okay?
But how are we going to get a number out of this?
How you going to get a number out of it?
Yes.
Good question. Okay, where do you think I should start? Here's my Venn diagram. Where do you think I should start? In where? In the center. What do you mean by the center?
What's in common?
What? Okay. What's in common with all three?
Right.
That's where you're going to start at. What's in common with all three? Then what you're going to do is working your way out. So you look at it and you see what do they have in common with all three. Okay? What do we know?
That 7 students take math. 0 students.
Nobody is triple majoring or double majoring with science.
All right? So that means that when we talk about here that even triple majors, this is going to actually be who? Zero, because of the fact that nobody's going to be a double or a triple major with science when we talk about that. So this is 0, and here's science, and it also saying a what?
That's the intersex between science and math.
Yeah.
These two right here, right?
Or 0.
Because nobody double majored with who?
Science.
With science. So this is 0 and 0.
And then, yeah, the 7.
7 is where?
In between math and English.
Math and English? Is what say math and English?
Yes.
Okay, double math and English. Math, and let's look at the word that say and. And is what they have supposed to have in common, right?
Right.
Math and English, and that's that and piece, that's that intersection. Okay? Now let me tell you something about that too. I want you to make sure you watch out for. When you talk about and, okay, because I could actually say that one of them had a triple major of English, science, and math. And if that one had went here, and let's say that this was 1, then what would this be?
6.
It would be 6 because you got to subtract out, because remember that it was already 7 that took math and English, right? So then this would actually be 6 because 6 and 1 do make what?
7.
Keep that in mind. Any questions on that? Okay? But because this one was 0, then this had to be who? 7. Okay? Now we can go on, and notice that we work in going out. So we did what all 3 had in common, then you go what? 2 at a time. Got it? Now you're going what?
Out.
Individually. You're going out because you're going out. So now we can do 40 of them were majoring in mathematics. So here's my mathematics circle right here. This is 0, this is 0, this is 7. But we said 40 of them, so this had to be who? 33. That was mathematics only. Didn't take didn't do any other major. They only did mathematics. That was it. Then it goes on to say that 20. No, that was 40 of them. 30 of them were majoring in what?
English.
English.
So
Okay.
it's 23.
So we got 23 here. Okay. Then it tells you that 20 were majoring in what?
Science.
20 were majoring in science. That goes here. Okay, and we already have 7 had a double major of mathematics and English. Now the question is, how many students had majors other than mathematics, English, or science?
I got 60.
Add them all up and subtract about what?
Add them up and take the number minus.
Minus 150. I got 60.
All right, so that means you take all of these in here. Everything here, and we talk about this, and that, right?
Right.
Because how many people did we survey?
150.
150. That is the number that's outside here. This is what?
60.
You said 60? Any questions on that? Let me pose another question. All right. How many took math and let's say how many took let's see if I want to pose that way. Okay, how many took math only?
33.
33. How many took math and English only?
56.
How many?
56.
Math and English.
Oh, math.
And 7. It's 7. It's math and English. Watch out for that terminology. Math and English, which means both of them. And it was only 7. How many took math or science?
53.
Math or science. What does or mean? What does or mean? Math is that, and or means that union, one or the other or both. It could be one or the other or both. That's what you got to understand about when we saying the terminology with or and and. If it's saying and, then both got to have something that has to have something in common. But if it's saying or, it could be one or the other or what they have in common. So I asked, how many students take math or science? That's this, and that. Remember that when we were doing or? That's what union is, isn't it?
Yes.
It's the or statement. So we're talking about 33 and who?
7.
7, which is who? 40 plus who?
20 is
20,
60.
which is 60. Take math or science. And if it was something in here, I would take that as well. You follow me? Any questions on that? Gotta watch out for that terminology, that language.
How did you get that's why I got locked up.
You come out here? Okay, so they're saying that 33 and 7 is what?
40.
40. Then you have 23 here. I don't know. You got 60 what? 3. This is what? 20. Should be more than that then. This is 60. 80 what? 83. So then you got to do 83 from there is what? What is it? 57?
Alright.
Yes.
Okay, so on a test, if you give us a question like this, are you looking to see if we do a Venn diagram, or are you looking to see if we take the information from the problem and do that and get an answer?
It depends. If I ask for a Venn diagram, then you got to draw a Venn diagram. Okay, if I ask for it. If I don't, then you're just writing it down. Because
Okay.
you don't have to necessarily do a Venn diagram with these. It's just another way of actually solving or finding a solution. Not necessarily have to do a Venn diagram.
Okay.
But there are some that you do. That it would help because it's like an organizer.
Okay.
Is there a reason you're not adding the seven between math and English towards
Towards the what?
the joint seven between math and English towards English?
I did.
30 is 20.
No, you.
It's supposed to be 30. If you have the
Oh, I already included it here. Can't double dip. I already included it here.
so you can only apply to math or English.
No, they already applied. We only applied. That is a good question. Don't double dip. It's already applied. When I did 33 and then I added the 7, I got 40. And then at that point, that was 20. That right there, that 7 was already included. That 7 is the one that takes math and what? Science.
The answer is 67.
All right, come on, y'all. Y'all subtract it. I ain't subtracting. All right, it's 67. Huh?
150 minus 86.
All right, let's see. 67, that's 0, that's 1. That'll give me what? 2. And at that point, that's 9, that's 15. All right, 67. That is the answer. All right. All right, any questions on that part? All right. I'm going to give you one. You're going to try. Here we go. And you're going to answer this one. You're going to draw and analyze a Venn diagram for it. Here we go. Here we go. Suppose that a group of 140 people were questioned about a particular sport. About particular sports, not even a particular sports. That they watch regularly. 3. And the following information was produced. like football. 70 like baseball. 40 like hockey. 40 like football and baseball. 25 like baseball and hockey. 28 like football and hockey. And 20 like all three. Here it says, suppose that a group of 140 people were questioned about particular sports that they watched regularly, and then the following information was produced. 93 like football, 70 like baseball, 40 like hockey, 40 like football and baseball, 25 like baseball and hockey, 28 like football and hockey, and then 20 like all three. Question is, first one, how many people like only football? And the next one is, how many people don't like any of the sports? That could be one of y'all falling in that category. How many don't like any of the sports? That's sad. That's like is that me? Got it down? Everybody got it down?
No, hold on.
Probably need to organize these Venn diagrams. You can figure it out without it, it's fine. But also, teachers, you need to know how to organize them. All right, you ready?
No.
Y'all ain't ready yet. All right, let's go. 2 minutes. me look. I give you 45 more seconds. Stop. All right? Now, when he said that, it says suppose a group of 140 people were actually surveyed about a particular sport or whatever. This is what they came up with. So I see that I have how many different sets here? Football, baseball, and what? Hockey. There's my 3 sets. I'm going to do a little Mickey Mouse eagle. All right? What you say? What you say? That one looks small. How about that? All right, I got football, we got baseball, and we got what? Hockey. Okay? Where I'm supposed to start at first?
What's in common?
What they all have in common, which is here, right?
Yes.
All 3. What do they have in common?
20.
20. 20 is here. So I got that. Okay? I'm going to take that one away. Then we can go 2 at a time. Let's go up. 28 like football and what?
Hockey.
All right, so football and hockey is here, right here. But I got 20 already there, so this should be who? 8 on. Okay? Got to remember the what?
Subtract.
Subtract out. Then we go to the next one. 25. 25 like baseball and hockey. Here is baseball and hockey. Overlap from here. Baseball here, hockey here. So overlap from here. It's 25. So 20 here. How many is this? 5. That's 5 only that like baseball and what? Hockey. Okay? At that point, 25 like baseball and what? And hockey, right? Do you see that?
Yes.
25 like baseball and hockey, but it's only 5 that like baseball and hockey what? Only. Got it?
Yeah.
Okay, going up. 40 like football and baseball. All right, so football and baseball is here. So this is should be who? 20 there. Any questions on that part? Good? Thumbs up? Anybody with a down? All right, now we're moving out. Going to the singles. 40 like hockey. Here is hockey. Now, if you look at hockey, we in that side, that circle, we already got what?
8,
8,
20.
20, which is 28, right? And then this is going to be 30 who? 3. So at that point, we're going to have how many here? 7 there. Baseball. Inside of baseball, this baseball circle right here, we got 20 here, 20 there, which is what? 40, and this is what?
45.
45, so this is what? 25. And that means only baseball, right? They don't like anything else, just only baseball. Okay? Here, we got 93 like football. So we got 20, 20 is 40, that's 48. So that means this piece is who? 40 what? 45. Now how many people were surveyed?
140.
140. So that means you got to take all these numbers, this, don't double dip, right? Because they're already accounted for. Take all those numbers inside of here, add them up, and subtract them from 140. What do you have? 10. That's outside of here. They don't like what? Alright? Not that they don't like nothing. They just didn't go. They were surveyed. The question was about football, baseball, and what?
Hockey.
Hockey. So they took out what again? This, and this. Add them up. It was 140 people surveyed. So you take that number and subtract it from 140. Questions?
So basically you always start from where they
count out what all four have in common and work out. Okay? Now, let's answer the question. How many people like football only? 45. They like football only. How many people don't like any other sport?
10.
There's 10 of them. That's one outside of here. Don't like any other sport. Any questions? All right. I have about 15 minutes. So you got to quit.